Hey everybody, welcome to video 2 on variation. And we already talked about direct variation, and now we're going to talk about what's called inverse variation. So we're starting here. Describe inverse variation. And it's not hard to describe. Basically, it means when one quantity increases, the other decreases. So that's what you're going to want to write here. So when one quantity increases, the other decreases. Okay, and what they mean here is they're talking about when you're talking about your quantities, you're referring to like whatever your x value is or whatever your y value is. You know, like in the previous example, I think we did euros to dollars with direct variation. Those quantities are going to represent your x and y and whatever those could be. Okay, so the equation for that's a little bit different. Okay, and it's going to be y equals a over x or y equals k over x, depending on your textbook. And this is the equation that represents inverse variation. And you'll see the words like varies inversely. So we're going to look at this general equation. Sometimes you're going to see it written as k. If you solve that proportion, k is actually equal to x times y. Okay, so that's a quick way to find your k value. So those are the three things we're going to use moving forward. So let's look at our example here in number 6, and we'll try to keep that equation up there for us. Okay, so let's look at what's given here. And it says, in example 6, writing and graphing inverse variation. Okay, so y varies inversely. So y varies inversely. That's the key there. Varies inversely as x. Okay. And y equals 4, okay, when x equals 5. So when y is 4, x is 5, write and graph the inverse variation. Okay, so the first thing we're going to do, if you're going to graph something, you should know the equation, the relationship. So we're going to find k, and from above we know that k is equal to x times y. And they already gave it to us. So k is going to equal, so when y is 4, x is 5. So we get y equal, or k, excuse me, equals 20. Okay, and so our equation here is y equals 20 over x. That's the equation. And so we got to be kind of smart about how we're going to graph this, and we can create a table of values. Okay, you notice I only have go up to 10, so if I plugged in 1 for x, it would be pretty tough because I'd need 20. If I did 2, I'd get 10. Okay. If I did 4, I'd get 5. So it drops down a little bit. So my graph isn't the best, but the graph is going to look something like this. It's going to come down. Okay? And then if we did negative 2, we get negative 10. And if we plugged in negative 4, we would get negative 5. Okay, so where am I plugging these values in? I'm plugging, making a table essentially. I'm saying, okay, x and y. Okay, if x is 1, 20 divided by 1 is 20. If x is 2, 20 divided by 2 is 10. And I used 4 because 4 goes into 20 5 times. So notice how x times y should equal 20. 1 times 20 is 20. 2 times 10 is 20. 4 times 5 is 20. And then I could do 10 and 2. Okay, and get 20. And so when you multiply x and y, it should equal that k value. And we see that there. And that's why I plotted those points. And that's why I can use negative numbers. So my graph, it should get close to the x-axis like this as I go. And we'll try to follow that. So there's kind of what our graph looks like. Not the best graph, like I said, though. It's hard to graph on the tablet. So let's look at example 7. Okay, so let's look at what they're giving us here. And we're going to look and see, given y, okay, there's that varies inversely as x, and y equals 4 when x equals 10, write and graph the inverse function. So let's go ahead and write that equation. So we're going to write and graph. So those are the two things it's asking us to do. You're going to write the equation, and then you're going to graph it. So let's look. We know that k is equal to x times y. That is never going to change for inverse variation. So k is equal to, when x is 10, So by substitution, and y is 4, we get k is equal to 40. So therefore our equation is y equals 40 over x. So there's our inverse variation. Okay, it's important to know if we were going to make a table now before we graph this, okay, I would go ahead and make some values. So I know that x times y should be 40, so you could do 1 and 40, 2 and 20, 4 and 10, 5 and 8, 10 and 4. And so notice those products, if you multiplied x times y, you get the k value. 1 times 40, 2 times 20, 4 times 10. Essentially, you're plugging each of those x values into that equation and simplifying. 40 divided by 1, 40. 40 divided by 2, 20. 40 divided by 4. You can go up to 20 here, and 40 divided by 20 is 2. Okay? And notice how as x increases, my y value decreases. So that was the whole thing in the first description there. When one quantity increases, the other is decreasing, and they decrease proportionally. So this is the first graph I'm going to have to just do by hand here. So we'll try this out. It's not going to be pretty, but we'll get the general sketch here. And one's going to be really tough, 1 and 40. Okay, so I might go 2, 4, 6, 8, 10, and we could go up by this could be 20, maybe 40 up here, right? We're gonna have to space this out, I think. So 20. Okay, this is a big graph, so it's not going to be proportional. I changed my axes a little bit. One's by 2s, one's by 5s. All right, so let's see how to do this. So these are by 2, so 2 and 20 would be here. Oh, I'm sorry, that's not 2, that's 2, 4, 6, 8, 10. Yeah, so we got to erase that, sorry. Make sure I have the right value here. 2 would go 2 and 20. Half of that, so like 1 and 40 would be like right here. Okay, so 2, 4 and 10. So about halfway, 4 and 10, maybe right here. Okay, 5 we can do, and then we can go out to 10 and 4. So 10, 20, 30, 40, maybe down here. And that's going to be a little better indication. See if I can make that connect with that curve. Not terrible. And we'd have the same thing on the other side here. So we'd have, we'd go down to, there's 20, negative 20, right, and negative 40. We could graph that too. And we would go simply, and here's our other branch. So you have 2 and negative 20, negative 1, negative 40. So the same thing, just mirrored over here. So 2, 4, and 10, so about halfway like this. And 2, 4, 6, 8, 10, 10, and 4, maybe something like this. So there's going to be some guesswork here, if you're sketching the graph, and my phone's ringing. Well, it's my daughter, so I'm going to have to pause and get back to this video, so hold on. Okay, we're back for our last example. It wasn't anything terribly important, but it was my daughter, and they were looking for something, so... All right, so we're looking at example 8. So we just finished this graph here. That's what inverse variation looks like. We'll talk a little more in class about that. Number 8, the time t varies needed to complete a certain race varies inversely. So there's your key sentence, or your key terminology, varies inversely. That's going to tell you the equation that we're going to be using for this problem. Okay, as the runner's average speed s. Okay, so the time t needed to complete a certain race. So basically it's going to be equal to t is going to be equal to k over s or a over s, okay? If a runner with average speed, so there's our s value, right, speed, so let's highlight that. Speed is 8.82 miles an hour, completes the race in 2.97 hours. What is the average what is the average speed of the runner who completes the race in 3.5 hours? So the first thing we need to do is find our k value. Okay, so we're going to look at, oops, let me make sure I have the right marker here. So we're going to have t is going to be equal to our original k times, or excuse me, our k times, or I'm sorry, let's try to do that correctly. Erase that, sorry. Okay, let's look at this. So k is going to equal t times s. Okay, our original speed here is 8.82. Okay, and we're going to multiply that by our time, which is 2.97 hours, which gives us approximately 26.195. Okay, so that's our equation, and so we're going to use that to find now. We have to find a new time. We have 26.195 over s, and so we're going to find the time, what is the average speed of the runner who completes the race in 3.5 hours. So now we have t. Okay, so we have 3.5 equals 26.195 over s. Okay, so we're going to make a proportion. You're going to cross multiply. Okay, and then we're going to hopefully not run out of space, and you're going to have 3.5s equals 26.195. Okay, and you solve for s by dividing each side by 3.5, and you get s is equal to 7.48, and I had miles an hour. Okay, and that's our final answer. All right, so that's inverse variation. If you have any questions or comments, please let me know, and we'll see you next time.